Very good morning, students. So in the previous video, we have started the new concept which is like interpolation and extrapolation, right? So it has less weightage but very interesting concept. The thing is, what we have discussed in the previous video, introduction of interpolation and extrapolation, as well as how the relation between two interdependent variables like x and y, x is a independent and y is a dependent variable, right? How to estimate the missing value in between or outside the range of dependent variables y. Clear? So what do you mean by interpolation? Estimating the unknown value of dependent variable to the known value of independent variable x within the range called interpolation. Estimating the unknown value of dependent variable y to the known value of independent variable x outside the range, that we call it as an extrapolation, right? Now some basic assumptions, the limitations which have to be followed to apply interpolation or extrapolation. What are those? Whenever you frame any table having x independent variables and y dependent variables, right, from x0, x1, x2 and so on xn, y0, y1, y2 and so on yn, if any value is missing among the y values, the missing value must be an exact value of x, right? That means there will be no sudden jump in dependent variable from one period to another period. Exactly, if y3 is missing, the y3 value must be a value of x3. It should not be having any sudden jumps from here to there, from one period to another period, right? That is the first assumption what we need to observe. And the second assumption is there will be a sort of uniformity. So in the values of dependent variable y, after estimating the missing value, either interpolated or extrapolated value, there must be a sort of uniformity. Uniformity in the sense like completely the dependent variables of y must have an increasing order or decreasing order. Am I clear? And the third one is there must not be having any consecutive missing terms. Consecutive missing in the sense immediately two missing values cannot be observed, cannot be found. Am I clear? So these are the three assumptions which we have observed in the previous video. Now in this video I would like to discuss about the methods of interpolation or extrapolation. Methods we are going to discuss now. So generally they are classified into two types. Number one, it's a graphic method, and number two is a algebraic method. In our syllabus we confined to only the second method, algebraic method, remember. So graphic method we have not been observed in PU-1 syllabus, only the algebraic method we are observing here. Now in that algebraic method again there will be a categorized into three kinds. Number one, binomial expansion method. Number two, method of finite differences. Number three, Lagrange's method, right? And the first method is a binomial expansion method. In this binomial expansion method, generally you might have seen in your SSLC like polynomial expressions, right? Polynomial equations. I think you have come across that concept, polynomial, in your mathematics, right? So what kind of expression it will be? Y equals to a0 plus a1x plus a2x square plus a3x cube plus and so on an xn. This is a kind of polynomial equation, and this equation we call it as a nth degree equation. Look at here, nth degree equation. By expanding this polynomial expansion with the help of binomial expansion method, we have one big expression like formula kind of thing. Using this polynomial expansion or expression or equation, this binomial expansion method can be calculated. But there is another method which we need not apply any formula. How to expand? Look at here, binomial expansion method. How to expand? We can expand any polynomial equation by using a triangle called Pascal's triangle. Very, very important in this chapter, Pascal's triangle. Look at here, the Pascal's triangle I have given here. If you observe, see, first one, next writing 1 and 1 here, again writing here 1, adding in between 1 plus 1, 2, again 1 writing. Again 1. See, both the corners 1 will be there, remember. So here 1 plus 2. Look at here. These two. 1 plus 2. 3. 2 plus 1. 3. Again 1. Got my point? Next again 1. 1 plus 3. 4. 3 plus 3. 6. 3 plus 1. 4. 1 writing. That is the fourth line, Pascal's triangle. Next fifth line. 1. 1 plus 4. 5. 4 plus 6. 10. 6 plus 4, 10, 4 plus 1, 5, again writing 1. One more thing, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and then 1. Clear? So this is the Pascal's triangle. Using this Pascal's triangle, we can expand any binomial expansion form, kind of this, y minus 1 whole power 5, yx plus y whole cube, like this, any kind of expression without using polynomial equation also can be derived by using the Pascal's triangle. So this Pascal's triangle is very much important, remember guys. Look at there once. So Pascal's triangle. Look at here, one more time I am drawing. 1. Pascal's triangle I am drawing. Look at here. 1, 1 and 1 here. Right? Again here 1. 1 plus 1. 2. Again writing 1. Next 1. 1 plus 2. 3. 2 plus 1. 3. 1. Next 1. 1 plus 3. 4. 3 plus 3. 6. 3 plus 1. 4. 1. Next 1. 1 plus 4. 5. 4 plus 6. 10. 6 plus 4. 10. 4 plus 1. 5. 1. Next 1. 1 plus 5. 6. 5 plus 10. 15. 10 plus 10. 20. 10 plus 5. 15. 5 plus 1. 6. 1. See, look at here. So this is called the Pascal's triangle, remember guys, which is very important to expand the binomial method and to calculate the interpolating or the extrapolating value directly by using this binomial expansion or the Pascal's triangle can be sorted out. Am I clear? So using this Pascal's triangle, see guys, here lines are written at n equals to 3. I will say at n equals to 3, which line should be taken? Where you can see 3, this line should be the n equals to 3 line. N equals to 5 means where that 5? Here. So this 4 line will be n equals to 5. Where is n equals to 2? Where 2 you can see? Here. So this is n equals to 2. And then n equals to 4. Where 4 you can see? Here. So this line is n equals to 4. And this one 6. N equals to 6. And this is n equals to 1. And this one is n equals to 0. So this way you please remember guys, if you know the n value easily, the nth degree, if you know easily, we can expand by using the Pascal's triangle. So please learn this triangle, very simple. Always the corner should be taken 1. Okay, so 1, 1 and 1. So again adding in between 2, again 1, 1 writing. So again in between these two, 3 in between these two, 3, again corner writing 1, 1. In between these two, 4 in between these two, 6 in between these two, 4, again writing corner 1, 1. Again here 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, again writing corners 1 and 1. Again here 5 plus 1, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, again corner writing 1, 1. So this is the Pascal's triangle. Are you guys clear now? Pascal's triangle. So generally, how you are going to expand Pascal's without Pascal's triangle, I'll show you. Now even without using Pascal's triangle, you know the binomial expansion method, right? By using the polynomial expansion. So how we are going to write? Suppose y minus 1 whole power 5 is given. Y minus 1 whole power 5. So this one how it can be written? First y5, y4, y3, y2, y1, y0. First learn writing like this. From y5, y4, y3, y2, y1, y0. So after writing this one, here plus, minus, 5 is there? No. 5 by 1 factorial plus 5 minus 1 by 2 factorial minus 5 minus 1 5 minus 2 by 3 factorial plus 5 minus 1 5 minus 2 5 minus 3 by 4 factorial minus 5 minus 1 5 minus 2 5 minus 3 5 minus 4 by 5 factorial. You got it? So this way the expansion can be written. Are you guys clear? So this way the expansion will be written, and ultimately what you get here, after splitting this one, you will be getting the expansion y whole power 5 minus 5 into 5 by 1 factorial is 5 into y power 4 plus 5 minus 1. So 5 minus 1 is 5 into 4 20 by 2 10. So you know factorials, right? Everybody, guys, you know the factorial. 2 factorial is 2 into 1. 3 factorial 3 into 2 into 1. 4 factorial 4 into 3 into 2 into 1. 5 factorial 5 into 4 into 3 into 2 into 1. So factorials I think you might have learned, you might have come across already, right? Now 5 into 5 minus 1 4. So 5 into 4 20 by 2 factorial is 2. So 20 by 2 is 10. 10 into y3 minus 5 into 4 into 3. 5 4s are 20. 23s are 60. 60 divided by 6. Again 10 into y square plus 5 into 60 into 2. 120. 120 divided by 24. 120 divided by 24 is 5. 5 into y power 1 minus, after splitting that 1 you will be getting 1 into y0. So this is how the expansion should be done, y minus 1 whole power 5, by using the polynomial expression, polynomial expansion, nth degree expansion. But so this is a lengthy process, using the formula and all, it's a very lengthy process, right? Now there is a simple technique which I am going to discuss now by using the Pascal's triangle. What is it? Look at here now. So y minus 1 whole power 5 is given. Here whole power 5 means definitely you take it as n equals to 5. 5 known values are there. When n 5 equals to known, which is the fifth Pascal's triangle according to the Pascal's triangle, just see fifth line. What is the fifth line? 1 5 10 10 5 1. So write that one first. 1 5 10 10 5 1. Clear? How I have written the expansion? And then from y5, y4, y3, y2, y1, y0. So from y5 to y0 you write down by using the Pascal's triangle. Directly you got the value 1 5 10 10 5 1, because n equals to 5, power n equals to 5 here, isn't it? So directly taking n equals to 5, checking the Pascal's triangle where n equals to 5 line, 1 5 10 10 5 1, that has to be written now. After writing this one, simple technique, plus minus plus minus plus minus. So one code, plus minus one code can be given, which is equal to 0. Always we have to equate it to 0 to estimate any inter or extrapolating value. Clear? See, by using such a big formula, this expansion we have got. Just by using Pascal's triangle, directly we can write the expansion. So which one is better? So this is the best way of expanding the binomial expansion form. Am I clear? Without using such a big polynomial expression and then again simplifying that, bringing that line, instead of that, just by seeing the Pascal's triangle where n equals to 5, it's not only a y minus 1 whole power 5, suppose y minus 1 whole power 3. So n equals to 3. What to write at n equals to 3? Where that n equals to 3 line? 1, 3, 3, 1. Right? So start from y3, y2, y1, y0. Plus minus equated to 0. Look at here. Such a very simple way to expand the form. So this is how we need to expand. Say y minus 1 whole power 6. Tell me now y minus 1 whole power 6 how to expand. Where is the 6th Pascal's triangle? 1, 6, 15, 20, 15, 6, 1. y6, y5, y4, y3, y2, y1, y0 equated to 0. And then plus, minus, plus. Very simple expansion. I hope I am clear how to take the expansion form, and using this expansion form we can estimate or we can predict the inter value. Not predict, we can estimate only the inter value or the extrapolating value can be calculated. This is the binomial expansion method. Are you guys clear? Binomial expansion method. So to apply the binomial expansion method, we have certain conditions. What are the conditions? Let us see. Let us see the conditions now. If you want to apply any binomial expansion method, how to identify the binomial expansion? See, problem will be given like this. Problem will always be given like this. 15, 20, 25, 30, 35, 40. Next, 32, missing, 47, 54, 61 and 65. See, just they will ask us to estimate the interpolating value, because within the range only the missing is there. Therefore, this is interpolated value. If the missing value is outside the range, then that will become extrapolating value. Now, for this interpolating value, missing value within. So, let us consider first y0, y1, y2, y3, y4, y5. So how many known values are there here? How many known values? 1, 2, 3, 4, 5. So 5 known values. Therefore the number of known values are 5. I am just explaining the steps. Step 1, what we need to observe? Immediately we need to observe how many known values are there. How many known values are there? N equals to 5 known values. Therefore n equals to 5 means what is the expansion form? Y minus 1 whole power 5. You guys clear? Y minus 1 whole power 5. Depending upon the known values, we need to expand that y minus 1 whole power 5 equal to 0. Clear? And then, if you observe the values of x, what are the conditions to be applied binomial expansion method? Condition number 1. The missing value of y must be a missing of particular corresponding x. Look at here. Fine. So this value y1 is missing. That y1, as we know the assumption, there will be no sudden jump. Straight away we should check. That is y1 is missing. For y1 missing, what is the value? X 20. So for 20 we need to calculate y1. So these are x0, x1, x2, x3, x4, x5. So these are arguments. These are entries. Clear guys? Now this value is missing. The missing of y must be a value of independent variable x. There will not be no sudden jump here and there. Straight away the corresponding value of x should be taken, the missing. That is condition number 1. Second condition, there must be a common difference. Look at here. Common difference is there. First 15, 20, difference will be 5. Next 20 to 25, again 5, again 5, again 5, again 5. So there must be a common difference between independent variable x values. Am I clear? For every binomial expansion method, these two conditions must be followed. The missing of y must be a value of x. There will be no sudden jump from one to another period. Straight away the corresponding value of x must be taken. Second thing is, the common difference between x should be there. Am I clear? So using these two conditions, this is how the problem will be asked. Now in the coming video, we are going to discuss problems on binomial expansion method. Fine. I hope I am clear about the concept, introduction of binomial expansion method. Let us solve the problems in the coming video. Clear guys? So thank you. Have a nice day.